Now, so this video, I'm going to talk about some specific hydrocarbons, specifically the ones that come from petroleum. So petroleum is a mix of different hydrocarbons. So ones that we call alkanes. So those would be things like methane, um, ethane, butane, anything that ends in ane. Those are the ones that are the saturated hydrocarbons. So they have all of their hydrogens attached, no double carbon bonds. Cycloalkanes, those are circular alkanes, so circular saturated hydrocarbons. And then some of the aromatic hydrocarbons that I talked about in the previous video. The petroleum that we have today, we are pretty sure it was formed due to the composition of marine life. So we've got petroleum and we have coal, which are both fossil fuels. And as best we can tell, they are both formed from the decomposition of dead organisms where there's no oxygen. And coal is pretty much confirmed because we do find pieces of fossilized, plants and so forth. So it's a pretty good indicator that petroleum is from buried marine life because it's found in areas that used to be oceans. The petroleum does accumulate in porous rock that then gets trapped underneath a non-porous layer. So that's what creates an oil field. If you've heard of a term of an oil field, it's a section of rock that has trapped the oil that has moved up through that rock over time. So rocks most of them kind of work more like a sponge than just solid rock. And so it's allowed the oil to move up through time. And the thing is that most people don't realize this. Each oil field actually has a different composition of hydrocarbons. So not all petroleum, not all oil is created the same. It's not all equal. So we'll have different parts of what I'm going to be talking about here in this video. So petroleum also is commonly called crude oil. In fact, crude oil is the general term for it. Petroleum, depending on the country that you're in, petroleum might refer to gasoline. Here we call it gasoline, and petroleum is kind of equivalent to crude oil. So crude oil is what you're seeing up here in this jar. It is this mixture of hydrocarbons coming from this oil field. And it's a mixture of all of these different hydrocarbons with an upper limit of 50 carbon atoms in the molecule. So nothing bigger than that. So what do? We dig it up, pump it out, and then we have to refine it because it's got all different types of hydrocarbons in it. And we can't use it as is. I mean, think about trying to put this in your car, right? It's not going to work. So we're going to refine it using distillation. And distillation is exactly what it sounds like. If you're familiar with the process of distillation with something like water, we're going to heat it up and we're going to separate the materials based on their boiling ranges. We're going to use physical properties, physical properties from an earlier video. We're going to use those physical properties of boiling to be able to separate the different products out of the crude oil. And so you can see here, this is a fractionation tower. And so the crude oil is going to be heated out here and piped in. The really heavy stuff is going to sink down as soon as it comes in. So you can see down here, that's going to be things like asphalt and tar. The lighter stuff is going to start moving up the tower. The tower starts to cool down as you go up. And so different parts of the crude oil are going to be pulled off as it goes up, as they recondense as liquid, because they cool down, they recondense. And so the different parts of the crude oil will be separated out. There is one part, the lightest of the hydrocarbons, that don't recondense on their own, and that's the ones that'll come off the top. Those would be things like the gas, natural gas is what you would hear it called. Those will then get condensed and pulled off up at the top. So just so you have an idea of some of the things, and we're going to talk about these. These are the names of some of these hydrocarbons that are coming out of crude oil. And then you can see some of the common names over here. So a wide range of materials are coming off of this fractionation tower. And you can see here are some more of them based on their number of carbon atoms. But the boiling ranges are the important part. So natural gas is going to come off, like I said, way up at the top because the boiling range is less than 0 degrees Celsius. So it's going to be staying as a gas versus these other guys, which have much higher boiling ranges. And so they're going to be broken off of that fractionation tower at different areas. So let's talk about who is coming off the fractionation tower. So the ones that come off at the very, very top are the small hydrocarbons. So these are the ones that are 1 carbon atom to 4 carbon atoms big. And so these are the ones that are gases at room temperature. So these are the ones with those really low boiling points. So the 0 degrees Celsius or lower boiling point. These can be pumped directly from the wells as a gas, but they are dissolved in the crude oil as well. And so they come off the fractionation tower. So you can get them both ways. Most of the hydrocarbons that we're getting out are going to be methane. So these are what we, like I said, these are what we call natural gas. So most of it's methane, that's CH4, that simplest of our hydrocarbons. We're going to get liquefied petroleum gas, LPG. So this is going to contain things like propane. And you're probably familiar with propane for things like cooking on the barbecue with a gas grill and so forth. Some of you may have propane for heating your homes. And so that's where this is coming from. And then the other small hydrocarbon that's coming off of this is butane. That's the C4 molecule. And butane, if it sounds familiar, there's a reason. And that's because butane is mainly used in lighters. So this is the fuel. If you have a refillable lighter, that's butane, is the stuff that's in the little refill. It's liquefied in the refill because it's been put under pressure. All right, so that's the small stuff. That's the stuff that comes off at the very top that, think about it. We use all of that. The next stuff that comes off right below those small guys is gasoline. So this is hydrocarbons that have anywhere from, move my head again, 5 to 12 carbon atoms. So, not too big, but bigger than what we had with things like our natural gas. So the thing is that when these come off the fractionation tower, off the distillation process, they're straight chain molecules. So they look like this guy up here. And you might think, well, so what? The problem is if you put that into your engine, it burns too fast because this just can burn right through, no problem. And this causes a phenomenon called engine knocking, and it can actually damage your engine. And so what we want to do is instead have branched molecules. If you can see, these guys have branches all over the place. These burn much slower. And so when we get the distilled gasoline off of the crude, it's all this guy. It's all straight chain. And this is actually related to the octane rating. Okay, that rating that you see, that number on the pump, is actually telling you how fast the gas burns. So the closer it is to 0, it's only this N-heptane, the straight chains. So a value of 0 means it's all straight chains. And if it is a value of 100, because that's the scale, it goes 0 to 100. If it's 100, it's all these branched guys. So how do you change the octane rating? Because when it comes out of the distillation tower, it's 0, right? It's a octane rating of 0. And if you look here at the pump, it's 87, 89, 91. So how do we do that? Well, we use a process that's called cracking and reforming. So what they do is they heat the straight chain hydrocarbons that come off the distillation tower until they break. So they're breaking them into those smaller pieces of the hydrocarbons, and then they use a catalyst. They use a chemical that will reform them into the branched forms. So they reform them into that other formation that we want. And so this is how you change the octane rating. This is also why that premium gas, that 91 octane rating, is more expensive, because the higher you get on the number, the more of the energy and chemicals you need to get those molecules built. And so that's why this is so much more expensive. But this actually eliminates more and more of those straight chains and more of that engine knocking. So that's why high performance cars require premium gas, because it will eliminate that wear on those engines. If you stop at the cracking form, right? If you stop here at the cracking and don't do the reforming, you can get low number hydrocarbons. So you can get the little pieces, and that's what we use for raw materials and plastics. So you can just get the small ones, but sometimes we can need more of them, of specific ones, so we can just crack the gasoline and get these low number hydrocarbons that we want. We can also make gasoline from cracking higher number hydrocarbons and reforming those. So there is a way to expand the gas supply. It does cost more though, because you're having to put in the energy and chemicals in order to do that. All right, so who else gets made from crude oil, from petroleum? Because those are the two big ones that we run into. But we use a lot of the stuff that is coming from this crude oil. So kerosene, so a lot of people think, well, yeah, okay, that makes sense. It's another fuel. So kerosene is used for all of these. So kerosene is made for lamp oil, heating oil, fuel oil. It's also converted into jet fuel. So another big set of fuels. By the way, as I'm going through this list, we're getting bigger and bigger. So the hydrocarbons are getting bigger as we go. The next one up is diesel fuel. So this one's obviously used mainly for transportation. This guy is a bigger hydrocarbon, so that's why the engines are built differently, because it has to be used differently. Motor oil and other lubricating oils. So these guys are actually, there's an advantage to them because they can be recycled. Gasoline, diesel fuel, kerosene, natural gas, those you burn and they're gone. Motor oil, if you take this back to your local mechanic shop or whatever, they can actually send it off and it can be cleaned, because the main problem is it's got all of your gunk from your engine and so forth in it. It just needs to be purified, filtered out, and they can then reuse the oil, because it's a pretty tough stuff, the hydrocarbons that make up motor oil, lubricating oils. And then petroleum jelly. So if it says petroleum jelly on it, It's made out of crude oil. And you can probably guess, getting into bigger hydrocarbons here because that stuff is a solid. Mineral oil is another one that comes off of the petroleum crude oil. Paraffin wax, so the stuff that makes candles, is if they're not made out of beeswax, they come from petroleum. Also, the wax for wax paper comes from this. And then the biggest set of hydrocarbons, as far as size-wise, is asphalt. So asphalt and tar that we mix with gravel and so forth to surface our roads, that is also coming from this. So you can see there's a lot of different materials and products that come out of crude oil. So even if we do stop needing gasoline, we're still going to need some crude oil production to make some of these other products unless we find replacements for them. All right.